So I made a video last class of multiplying rational expressions. And so this is a second video. I'll call it video number 2, and I post it on Schoology. We're doing the same thing, basically just doing more examples, okay? So multiplying rational expressions. We're going to call this part 2. It's just more examples of like what we did last class. Make sure we got it. Because it's the factoring that gets us. The factoring and knowing what to cancel. All right, so ask me questions when I do something you don't understand. Right. Well, all right, so let's start with example 1. 8a plus 40. 8a plus 40 divided by 16a plus 72 times 4a plus 18 divided by 7a squared. All right, so the first thing I do not go and distribute everything. I would not do that, okay? Sometimes you're going to wind up with a big old mess. So what I would do first is I would factor any numerator or denominator possible to see if any of my factors cancel out. Because if they cancel out, it will make the problem a whole lot easier to simplify, okay? But you have to be able to tell if something's factorable or not, okay? It might only be a GCF, or it might be a quadratic that we can factor by grouping. So let's look at 8a plus 40. Is that a linear expression or is it a quadratic? What does linear mean? Linear means the term with the variable. If you have more than one term, it's the term with the variable with the highest exponent. So I only have one term with a variable, and a's exponent is 1. So we say that this expression has 1 degrees, okay? 1 degrees we call linear. If I had 2 degrees, like 7a squared has 2 degrees because a's exponent's 2, there's no other a's, that's called a quadratic, right? Linear expressions. If it's linear, the only way to factor it is if it has a greatest common factor. If it doesn't, then it's not factorable, okay? Does GCF have a does 8a plus 40 have a GCF? Well, I know 8 and 40 are both even, so 2 is a common factor. What I always do is I look at my smallest number, right? 4 is a common factor. Is that the largest one? What are other factors of 8? We know 2 and 4 and 8. Well, 8 divide into 8a and 40 evenly. 8 times 5 is 40. So we want to take out our greatest common factor. So what is it? 8. So we write the 8 outside parentheses. A lot of you keep continuing to just make the 8 go away. It doesn't go away. Then we divide each term by 8. Whatever's left goes in parentheses. What is 8a divided by 8? A. What's positive 40 divided by 8? Positive 5. Now look, what I have left here should be equivalent to what I started with. It's just written in a different form. If you don't put that 8 there, is a plus 5 equivalent to 8a plus 40? No. But if you leave the 8 and distribute, 8 times a is 8a, 8 times 5 is 40, right? They're equivalent. If you don't put the 8, you messed it up. So when I rewrite this, I'm going to rewrite 8a plus 40 in factored form, but I'll come back to it. Let's look at 16a plus 72. Is that a linear expression or a quadratic expression? Remember, a to the first is linear. A squared is quadratic. It's linear. So the only way to factor a linear expression is if there's a greatest common factor. You can't do factor by grouping on a linear expression. That's only for quadratics. So always look at my largest number. Will 16 divide into 72 evenly? Will 16 divide into 72 evenly? Y'all have calculators on your desk, tell me. No, so 16 can't be a GCF. Your GCF can't be any number larger than the smallest number. So give me another factor of 16. 8. 8 divides into 16 evenly. Does 8 divide into 72 evenly? You got a calculator? Yes, it does. So the only factors of 16 are 1, 2, 4, 8, and 16. 16 didn't work. The next largest one is 8. 8 will divide into both terms evenly. So 8 is my GCF. Okay? So I'm going to put an 8 outside the parentheses. Divide each term by 8. Whatever's left goes inside parentheses. So what is 16a divided by 8? 2a. What's positive 72 divided by 8? 9. If I would have say I said my GCF was 2. If I would have factored out a 2, what's inside parentheses would still have a GCF. That would let us know, like, hey, I took out a common factor, but not the greatest common factor. Okay? So I can't do any more factoring here. I'll come back to it. Now let's look at 4a plus 18. Is that linear or quadratic? Linear. So the only way to factor a linear expression is if it has a GCF. All phones should be in backpacks, not hiding behind sweatshirts or behind hats in backpacks. 4a plus 18. Will 4 divide into 4 and 18 evenly? No. What's another factor of 4 besides 1? Because of 2. Will 2 divide into 4a and 18 evenly? Is there any number higher than 2? Can't be larger than 4. It's got to be a factor of 4, right? So 2. So we factor out a 2. So not just 2, but 4a divided by 2, 2a. And then plus 9. What's inside parentheses is still linear. There's no GCF, we're good to go. Now 7a squared is a monomial. That means it's one term. It's not 2 terms added together or 2 terms subtracted, it's just one term. So when you have monomials, you don't need to divide those, okay? So now I'm gonna rewrite my problem, and any numerator or denominator that I factored, I'm gonna put in a factored form. So instead of 8a plus 40, I'm going to put 8, open parentheses, a plus 5, not 8 plus 5, divided by 16a plus 72, factored into 8 times 2a plus 9. And remember, when I multiply fractions, I do numerator times numerator, so, and denominator times denominator. So I'm just going to go ahead and put everything in one fraction. 4a plus 18 factored into 2 and a 2a plus 9. And 7a squared was just 7a squared. Now, eventually we're going to multiply everything together, but if anything will cancel out, you cancel it first and then multiply, okay? Yes, 2a plus 9. divided by 2a plus 9 is 1. We say it canceled. Right, 8 divided by 8. Can I cancel the a from the a plus 5 and the a from 7a squared? No, a plus 5 only cancels a plus 5. It's two terms. Two terms have to cancel another two terms that look the same exactly. Now, if 2 and 7a squared, if those could reduce, I could reduce those because they're both one term, monomials. So you can reduce one term. It doesn't have to be identical. But 2 and 7 don't reduce, and there's no a's with 2. So, like say this was 2 and this was 4a squared. Then we could reduce the 2 and a 4. So 2 would cancel. 2 divided by 2 is 1, and the 4 would turn into a 2. Because 2 divided by 2 goes into 4 twice. Yep. But it only has to be, it has to be a monomial to be able to do that. Binomials, like a plus 5 is a binomial, two terms. A plus 5 only cancels an a plus 5. Not an a, not a 5. So whatever we have left in the numerator, we'll multiply it together. Whatever we have left in the denominator, we'll multiply it together. So in the numerator, we had an a plus 5 and a 2. So since the 2 is a monomial, we usually put that in front of binomials, right? Over, only thing left in the denominator is 7a squared. Sometimes you'll see it left like that. Double check, is there anything that can reduce? Because if I might have gotten to reduce something, then I would see it here. But if not, I can leave it like that, or I can distribute that 2 to get 2a plus 10 divided by 7a squared. Can I reduce those a's? Nope, still no, because 2a plus 10, two terms that go together. 2a plus 10 only reduces with 2a plus 10. Julio? Julio. Yes, so restrictions. Remember, restrictions are values that will give me an a in the denominator, a 0 in the denominator. So go back up to your problem, look at your problem when the denominator was factored. It doesn't matter if a 0 is in the numerator. You can have a 0 in the numerator. It's a denominator. We have three factors. Set them all equal to 0. Let's start with 8. Can 8 equal 0? No. If there's no variable, you don't get a restriction. So I'm not going to get a restriction from 8. There's nothing to plug in for a variable, right? 2a plus 9 has a variable. So I'll get a restriction from that. Set it equal to 0. Solve for a. So what would I do to solve for a? Subtract 9 from both sides. So 2a equals negative 9. Divide by 2. And a equals negative 9/2. So that's a restriction. We don't want a to equal negative 9/2. Notice I put an equal sign and a little slash through it. That means a can't equal that because that would give me a 0 in the denominator. Because 2 times negative 9/2 is negative 9 plus 9 is 0. 7a squared is the other factor. Set it equal to 0. How will I solve that? 7a squared equals 0. What should I do first? Divide by 7. 7a squared divided by 7 is a squared equals, what's 0 divided by 7? 0. Since a is being squared, we have to square root both sides. The square root of a squared is a. The square root of 0 is 0. 0 is my other restriction. So my answer is either of these fractions. 2 times the quantity of a plus 5 divided by 7a squared, or I could say 2a plus 10 equals 7a squared. That's the answer. These are my restrictions. This is saying this is true as long as a is not equal to negative 9/2 or 0. And that comes into play a lot when you're solving rational equations too. Okay? Coolio. I'll just do 2 more because like I said, we did these several last class. This is just a review. You weren't here, I posted the video on Schoology. Let's look at r squared minus 11r plus 30, quantity divided by r squared minus 25. And we're going to multiply that by 2r squared plus 8r, quantity divided by r squared minus 2r minus 24. Okay, now this one's got a lot of factoring, okay? But that's okay, we got this. We know how to factor. We are master factorers, are we not? We're gonna be, we need to be. Look at the top left numerator. Is that linear or quadratic? Quadratic, because negative 11r is linear term, but you look at the term with the highest degree. Your highest degree is 2, we call that a quadratic, okay? Quadratics, if they're factorable, that's when we do factor by grouping. Linear, if it's factorable, GCF's all you got. Quadratic might have a GCF, but we also might be able to do factor by grouping. So I'm going to take that over to the side and see if I can factor it. Does it have a GCF? No. You always ask that first, no matter if it's linear or quadratic. Okay, well, what is A equal to? 1. What is B equal to? And what is C equal to? 30. So if it's factorable, we'll need 2 numbers that multiply together to give us AC, which in this case is positive 30, and add to give us B, which is negative 11. So don't worry about the negative 11 right now. Just what can I multiply to get 30? 15 and 2. So 15 times 2 is 30. What's 15 plus 2? 17, right? Even if I did negatives, negative 15 and negative 2, and added them, I get negative 17. So 15 and 2 won't work. What else can I multiply to get 30? All right, 6 times 5 is 30. 6 plus 5 is positive 11. Right, we need it to be negative. So if I do negative 6 times negative 5, I get negative 30. And negative 6 plus negative 5, I get negative 11. So you got to pay attention to your signs. I'm like so tight on space. So remember, the negative 6 and negative 5 are what I'm going to reuse to write negative 11r. And they have to be equivalent, so I'll put a negative 6r minus 5r. So I have r squared minus 6r minus 5r plus 30. Is negative 6r minus 5r give me negative 11r? Yes, Miss Freely, it does. It does. Because if I accidentally use the negative 30 and negative 11 here, well, negative 30r minus 11r does not give me negative 11r. Okay, so be careful about that. So we group our first 2 terms together and our second 2 terms together, and we factor out a GCF. Even if it's just a 1, we have to factor it out, if that's all we have. So look at my first group, r squared minus 6r. What is the GCF? R, just an r. So I'll divide each term by r. What's r squared divided by r? R. What's What's negative 6r divided by r? What? negative 6. What's going to be the sign of my next GCF? Negative, because it's whatever the sign is of the first term in the second group. And what is the GCF? 5. So we're taking out a negative 5, okay? So I'm dividing each term. Sorry, this is so squished up. What is negative 5r divided by negative 5? R. What's positive 30 divided by negative 5? Negative what? 6. Is this factorable? Is what's inside parentheses identical? Yeah, even though it's hard to see on my paper. If what's inside parentheses is identical, it's factorable. What goes in one set? R minus 6. What goes in the other? Boom. So I'm going to go and rewrite this up here. So my numerator on the left side factors R minus 6 and R minus 5. Now let's look at R squared minus 25. Now this is a special case. We've talked about it before. You've learned it before, definitely, in previous math classes, for sure, Algebra 1. Is R squared a perfect square? Is R squared a perfect square? Yes, because R times R. When you multiply the same factor together, the result's a perfect square. Is 25 a perfect square? Yes, because what times itself is 5 times 5. When you have a perfect square minus a perfect square, it's called a difference of squares. Soup's easy to factor. We don't even have to do T-chart and factor by grouping. We can, but you have to be careful because a lot of times we make a mistake. If we were doing T-chart divide and slide, which I'm not, but what would A be? What would A equal? 1. What would B equal? C would be negative 25. That's your A. Look, A is always the coefficient of the quadratic term. B is always the coefficient of the linear term. C is always the number that doesn't have a variable. That's a constant. So we have a quadratic term and a constant. We don't have a linear term. So whatever you don't have is 0. So A would be 1, B is 0, C is negative 25. Okay, so if you're doing it that way, but look, if it's a difference of squares, we can factor super simple. Here's what you do. You ready? Make 2 sets of parentheses. This is called an identity. That means it works every time. And one set of parentheses, put a plus in the middle, and the other, put a minus in the middle. The first term in each set of parentheses is the square root of the first term. What's the square root of R squared? R. So it's going to be the first term in each set. The second term in each set is the square root of the absolute value of the last term. So don't worry about the negative. Absolute value of negative 25 is positive 25. What's the absolute value of positive 25? Did I say what's the absolute value? What is the square root of positive 25? 5. Factored. That only works if you have a difference of squares. So my bottom left factored into R plus 5 and R minus 5. Those are so easy. If you know the identity, you can do it super fast. Now let's look at the numerator on the right side. 2R squared plus 8R. 2R squared plus 8R. So right now it's a quadratic, but even if we have a quadratic, we look to see if there's a GCF. Do we have a GCF? What is it? Just 2? 2R, very good. 2R. Because my first term has 2 R's. R squared means R times R, there's 2 of them. 8R has 1 R, not 8. It's the exponent. So I've got 2 R's in the first term, 1 in the second term. Do both terms have at least 1 R? Do they both have at least 2 R's? No. So all I can take is 1 R. And then obviously 2, because 2 goes into 2 and 8 evenly. So my GCF is 2R. I'm going to divide each term by 2R. The R what? Just R. 2 divided by 2 is 1. R squared divided by R is just R. Plus 4, because I only had 1 R. I took it out, right? The R's cancel. Now, we started with a quadratic, but what's inside parentheses? Is that still a quadratic? No, because we took one of the R's out, so what's left is linear. Remember, if this was still a quadratic, I could probably factor further. But because we took one of the R's out, now it's linear. So linear, the only thing we can do is factor out a GCF if there is one. If there's not, that's all we have. So this is factored. So 2R and R plus 4. So the only thing we have not factored yet is R squared minus 2R minus 24. And I'm kind of running out of room at the bottom, so I am going to add on a little section here. So R squared minus 2R minus 24. This is a quadratic. 2 degrees is quadratic. Yes, it has a term with 1 degree, linear, but you look at the highest one, and that's what we call, that's what we say is the degree of the whole thing, okay? So we can hopefully do factor by grouping, unless we take out a GCF and then it's not a quadratic anymore. So do we have a GCF? What? Just 2 divide into this term. No, got to divide into all of them. Does this term have an R? No. Do all terms have at least one factor in common besides 1? No, so we say no. What is A equal to? 1. What is B equal to? -2. What is C equal to? -24. Make our little T-chart. A little more room now. On the left side, I need 2 numbers that multiply together to give me A times C. What is A times C? -24. And I need 2 numbers that add to give me B, which is -2. -6 and +3. -6 times +3, that's -18, that won't work. -6 and +4. -6 times +4 is -24. -6 plus 4 is -2. Perfect. So it's the -6 and +4 is what works on both sides. So that's what I'm going to use to rewrite my middle term, but we got to put an R with each of them, right? So the R squared, we bring it down. Does it matter if I put the -6 first or the +4 first? No, I just usually write it how I see it. So -6R plus 4R. You have to put an R with it. Is -6 plus 4 is -2. It needs to be -2R. -6R plus 4R is -2R. Bring down your -24. Cancel what? Yeah. All right, group my first 2 terms together. Group my second 2 terms together. What's the GCF of the first group? R. Remember, when you're doing factor by grouping, not the original GCF, but once you get to this point where you group them together, if your only GCF is 1, you got to take it out. Because our answer, we need 2 terms in each set of parentheses, right? So I'm going to divide each of those terms by R. What's R squared divided by R? R. What's -6R divided by R? -6. What's going to be the sign of the GCF of the second group? Positive. And what is the GCF? 4. Very good. So I'll divide both of those terms by +4. What is positive 4r divided by 4? What? R. Negative 24 divided by 4? Negative 6. Is this factorable? Yeah, remember, if you get to this point and what's inside parentheses is not identical, it's either not factorable or you did something wrong. Okay, because not everything's factorable, but we know it is, so we're going to make 2 sets of parentheses. What goes in one set? And the other? Is it okay if I put r plus 4 first and then r minus 6? Yeah, doesn't matter. So that was the bottom right, so make sure we put that on the bottom, the denominator. You do not want to multiply all of this together until you've canceled any common factors. That was the whole point of factoring everything. All right, will anything cancel? What? All right, r minus 6 divided by r minus 6 is 1. We say it cancels. R plus 4 divided by r plus 4 is 1. We say it cancels. R minus 5 divided by r minus 5 cancels. Can I cancel the r in the numerator with the r in the denominator? No, because r plus 5 only cancels with an r plus 5. It's 2 terms, binomial. 2r, if there was another monomial, 1 term in the denominator, then I could reduce those if possible, but there's not. So what's left for my numerator? 2r. If nothing was left in the numerator, you put a 1. Okay, what's left for the denominator? R plus 5. And again, that r and that r do not cancel. What do we have left? So this is the answer. What do we have to do after that? Exemptions or restrictions or excluded values, they all mean the same thing. Different programs call them, or different books call them different things. So exemptions are what r cannot equal. These denominators look a little easier to figure out because your coefficients are 1 on all of them. So for r plus 5, what would my restriction be? Negative 5, because negative 5 plus 5 is 0. We don't want 0. For r minus 5, what would your restriction be? Positive 5. For r minus 6, positive 6, because 6 minus 6 is 0. And for r plus 4, negative 4. So that means that this is true as long as you don't substitute in a value for r that's positive 5, negative 5, positive 6, or negative 4. Because if it's one of those, then this is not true. Coolio? Again, we did multiple examples on Tuesday. If you weren't here, if you need to go back and watch that video, it is on Schoology, and I'll post this one as soon as it's ready. Also, for a while, I don't know what the cutoff date is. It might be tomorrow. For students won't have access to YouTube at school. It might have been, I don't remember the date. They're trying to get that fixed. It's not that they're taking it away permanently. There was some sort of, when something uploaded and changed, I don't know, like it changed the settings on the YouTube, I don't know. But for a little bit of time, we don't know till ever it's fixed. They get it worked out. You will not have access to YouTube. So for my videos, if you're absent, you'll need to watch them at home. Okay. All right, so I'm going to end my video and give you your assignment. That will also be on Schoology.